To calculate how much actual stress is on your slings when you're lifting something, and the slings are on an angle other than not on a vertical, not in the line of pull, it's fairly straightforward. Look at the numbers that we have here from our measurements. Like I said, in position 4, as the load is being lifted in this position, it's nearly twice as much stress is being placed on the two slings combined than the actual weight of the load. That nearly 2, I want to have a real number, so I'm going to divide that one by that one to get an exact number, not just nearly 2. So I'm going to go 860 divided by 465. I got 1.8. Just ignore the rest of the decimals for now, just graciously, okay? And there, 1.8. I'm going to record that one. And the stress, that we have a stress factor of 1.8 at this lifting situation or location. The previous one was 624, so I'm going to divide 624 by that number by that, and 490 by 465, and I'm going to have these stress factors here. You just 3 more straight divisions, just give me a sec here. 624 divided by 465, that's a stress factor of 1.3. The other number was 520 divided by 465, that's a stress factor of 1.1. And 490 divided by 465, that's 1.05. Okay, so those are my stress factors. Now do notice that on your rigging handouts you have typically angles mentioned on your papers. There it is, I found it. Okay, there, that's what happens. Typically you have angles. A sling angle of 60 degrees is what it says, a sling angle of 45 degrees, and a sling angle of 30 degrees. Well, that's cute, but we can't measure angles on a job site reliably. Okay? Here's the same picture. I just click, copy and paste, you know. As the included angle between the legs of the sling is getting greater and greater, the original 1-ton load is placing a 6-ton stress on the slings, or a 2-ton stress, or a 1-ton stress each leg of the sling. Okay, same idea with this one. So for your calculations, because we don't have angles on the job, nobody is walking around with a protractor or a compass, we're gonna use the length of the sling, which runs this way, and the headroom here. And for these calculations, when I do take a measurement for headroom, I will try my best to measure from the point of contact there to not to the underside of the hook, but where the triangle, the imaginary hypotenuse of the triangle meets with this vertical. So it's above the hook a little bit, somewhere there in the air. Okay? The numbers that you need are, I'm gonna go metric with this one because I don't want to work with fractions, so I'll do my best to line up my tape measure, and I'm reading 245 millimeters that way, and 140 this way. 140. So vertical or headroom is 140 and length is 245. Okay, that's what I wrote down. Length is 245 millimeters, height was 140 millimeters. It could be inches, it doesn't matter. Now, if you divide, again, the greater number with the smaller number, you can get the same stress factor. I'll show you. 245 divided by 140 equals 1.75. Okay, it's not exactly 1.8, but it's close enough to be 1.8. What you can do with this stress factor is that once you calculated, and you can see it on my weight calculation video, how the weight of the concrete is figured out using this tape measure. Once you have that weight of the object that's being lifted, you can calculate quickly how much stress it's placing on the slings if you have the stress factor. And that stress factor comes from dividing the length of the sling by the headroom. I'm going to repeat it just 1, 2, 3 more times so you can see consistently that you do get that stress factor. So if I change the position there and there, where we had 310-ish readings, then I'm just gonna grab my tape measure again and measure the length much the same way. I'll do my best to measure it nicely, and I'm reading 235 millimeters for length of sling, 235, and for height I have 185. So the new height is 185 and the new length is 235. Okay, all I did is I just wrote those numbers down. If I again divide the bigger with the smaller, I should be getting back the 1.3 stress factor. Let's see if we actually do. 235 divided by 185 equals 1.27. I say, we're on to something. Okay. You know what, I'm not going to repeat those the same calculations, or I'm not going to repeat it 2 more times, and I'm not going to take measurements. I'm just going to write up something here on this sheet of paper. To calculate the stress, to calculate the stress in the sling, in slings, this is what you do. You take the weight of the thing and you have to times it by the stress factor, and that stress factor is coming from dividing the length of the sling by the headroom. Okay, so that's your calculation or formula. It's super straightforward. There you go.